Hello, I'm Jody Michaels at FANUC America. I'm the Director of Aftermarket Support and Business Development. And today we're going to talk about manufacturing automation.
All right, Jody, thank you so much for joining me today. I really appreciate it.
Well, I love being here. Anything I can do to help LaBelle.
Hey, yes, you have helped us more than we can probably thank you for over these last years. Obviously, I know who you are, but could you tell the people watching your name, where you work, and what you do there?
Yes, my name's Jody Michaels, and I work for FANUC America. My current title is I'm Director of Aftermarket Support and Business Development, which involves a lot of things. I've got 15 guys nationwide that work for me, and mainly it's customer satisfaction stuff is what we do.
Now, you say your current title. Does that mean we're going to be dipping into some other things, or?
Yes, well, since I've been at FANUC, I've sort of been in a lot of different roles. I've been with FANUC for 10 years, and I started out as an account manager in aftermarket. And then I became the national sales manager for 8 years, where, I was overall system sales in North America, South America, and, all those areas. And that was over all that. And then 2 years ago, I took on this new role. And it helped me get back into more of a technical role, which is what I really like to do, actually. And you know that. Yes,
and I know you have obviously a very long history of manufacturing. You've been with FANUC for 10 years, but it streams back way farther than that. Can you tell us a little bit how you got started in manufacturing?
Yes. In 1977, before that I was working construction, actually, building mobile homes. But I started at Cincinnati Millicron in Wilmington, Ohio in 1978 as an engine lathe operator. And I ran a machine for like 15 years. And I went from an engine lathe to NC machines and CNC machines. And at Millicron, it was great because if you wanted to learn, they'd teach you everything. So I worked in a gear and spindle cell. So I learned to run gear machines, grinders, mills, lathes.
You've done it all.
I have. And like I said, if you're willing to learn, they would teach you. And I love that, And plus, it's one of those deals that once I started doing it, I loved it because, you can take a piece of metal and make it into something. So at the end. And then after that, Wilmington closed after 15 years where I was working at. I transferred to the main office of Millicron in Cincinnati. And there I got into application engineering for about 5 or 6 years. And then after that, I started getting into sales support. But then in 2001, I got laid off from Millicron. And then I started at Romy, which is a Brazilian builder.
Yes.
And there I started out as the application manager. And after about 2 years, I became the application manager, the national sales manager, and the service manager. I was over everything but the money.
Right.
And it was a great experience. I got to go to Brazil a lot. Romy's a great company. And then I left there in 2011, and that's when I started with FANUC. And like I said, I went through a lot of different jobs at FANUC, but it's been a great career. I love machine tools. I love manufacturing. I love automation. It's been a great ride.
It sounds like it.
I totally enjoy it working with people like you and LaBelle. It's so much fun. Helping young people. Come up through the ranks.
Well, we appreciate the help, and we always appreciate when you come out here to tinker with us. So obviously you've had a very long career and you've probably seen a lot of innovations over that course. What would you say was the best innovation? Like when something came out, you're like, oh my gosh, this is where the future is, over your career.
Well, the development of robotics and automation into our industry, compared to what it was 40 years ago when I started. Because, back then there wasn't anything like those types of robots. And, it wasn't until like the late 90s, early 2000 that robotics started getting into that. And, some of the things that you see with robots today with vision and all the different things that it'll do, it's kind of scary, actually. It's almost it's like Terminator-like stuff. Especially, when you go see our factories in Japan, where you have robots building robots and robots building controls, especially on the volume of stuff that we do, where we're building 5,000 robots a month. I mean, it's kind of amazing, the volumes of stuff that we do. So I think, that's a differentiation between what it was when I started, when it was all manual load, unload stuff, to what you see today. And it's only going to get more and more of that. You see that.
And where do you see the future of manufacturing going if you had to take a guess in the next 10 plus years?
Well, because we're getting into so much of this artificial intelligence stuff, which just blows me away that even in machining, because to be honest, I'm a good machinist. But some of the stuff that you see that robots can do anymore, and I got to tell you this story there's something at our plant in Japan where they do robo drill bases, right? And there's this one part, it's a casting where it could vary in size, this one edge, but you have to break the corner on this edge. You could never program to allow for that. You could, because it varies.
Right.
But so they take it off and put it on this stand, and this robot comes and looks at it and determines how to break the corner. And then it picks up a deburring tool and breaks it. And it just blows me away to watch that robot do that. Because it's so smart. It understands what size it is, how big the circle is. I mean, it's just stuff like that. It'll almost be able to replace people like me and you, but not quite.
I was just about to ask, do you think it'll get there where the machinist isn't needed anymore?
No, never. Because, and I know you've seen this as well, because over my years in manufacturing, somehow I always ended up being the last resort guy, right? Where if something was wrong, they'd say, well, send Jody, he'll figure it out. I don't think you'll ever get a robot that'll be like that.
That's true.
Because you know what I mean? You have to sort of think outside the box sometimes to solve something.
Yeah, robots are programmed to follow one thing,
They're logical. Sometimes logic makes no sense to really fix something. Sometimes it's something way out in left field.
Absolutely. So I know that one of your big passions is education, and that's something that we've all been working together on. What advice would you give students right now considering a career in manufacturing?
Well, I think that, and this too, that over the years we pushed having a college degree. And when I talk to students, because I do career days all the time, I don't have a degree in anything.
I didn't know that.
No, I don't. But, I just learned on my way up. And, when you tell kids that, they get, I try to tell them, you don't have to have a degree. You should go to tech school, though. You should go to tech school and learn the basics first, because I had to learn the basics on the job. But, you can get somewhere even without a degree. And it's funny though, whenever I do career days, you know what the first question they ask, right? They always say, how much money do you make?
Oh, that's a good one.
That's always the first question. It's always is. And when I tell them, they say, you don't have a degree and you make that much money. And I said, yes. Granted, I worked my butt off to get here. I was
just about to say, there's a lot of hard work behind all of that.
But then, they see in me that an ordinary guy that made it to a high level.
Yeah. But I think one thing we can see from your career is obviously you had that drive and determination to work your way through that. So, absolutely.
Even when I didn't want it sometimes.
Yeah.
Because to be honest, when I started at FANUC, I had no ambition about moving up, to be honest. I did.
Okay.
But you know how it is when you see things that it shouldn't be like that. I mean, like helping you guys. In the education field. In the beginning, they said, you'll never get the prices that you want to get for LaBelle. Yeah. And we did. We did it where you could afford to buy a FANUC instead of using something cheaper.
Yeah. And that's made a big impact in the schools because now we have students, learning on industry controls, and then they can take those skills and they can work, almost anywhere. So
exactly.
I think that's huge. So Jody, something that we do is we put out a poll, and we wanted people to ask, what questions they have about manufacturing and CNC. Would you mind helping me answer one of those questions?
Sure, no problem.
All right, so the question is, how long does it take to learn to operate a CNC machine control, and are they complicated? What would you say?
Personally, and I train a lot of people, so typically I can train somebody in 2 days to actually operate a CNC, even if they're a total rookie. Granted, will they know all the programming that quickly? No, but to actually operate it, it's not that hard. As long as you're somewhat logical and pay attention. Yeah. But anymore, it's funny. Most kids today, they want to learn. They want to learn, no matter. Can I tell you a quick story about a place where I went?
Yeah.
I went to this place in Wisconsin to train a couple guys on a vertical mill. Mm-hmm. Well, I walked in, and it was two brothers. One was 23, one was 24. And they had these crazy haircuts where on one side of their head it was bald, and then on the other side it went to their shoulder.
Okay.
And, as soon as I saw it, I thought, this is not going to be good. I was like, I know these guys are not going to pay attention, but it was totally different. Mm-hmm. Both of them, they wanted to learn so much that at one point in the afternoon, I was trying to explain something, and the older brother looked at his other brother and said, "Shut up. I want to hear what he's got to say." It was so funny.
Awesome.
But, you can't go by appearances today because, you get a lot of different looking people and a lot of women as well, which, you see a lot of women in tech schools anymore learning to run CNCs. So I love to teach kids. I love working with young people.
Yeah, and that's the great thing is, I've seen you and how you explain things, and you're really great about, because you've had the experience, you've made the mistakes, and you know how to tell them, like, I've been there, guys, like, this is how, what works, this is what doesn't. So a fun thing is you have one of our very first 5-axis machines, thanks to your patronage here at LaVille. What plans do you have for that machine? What are you most looking forward to working on it?
Well, we're going to do a variety of things, actually, because we're trying to get to where, number one, most of the big builders that import stuff into the U.S., a lot of times their 5-axis machines are not set up correctly. Mm-hmm. So we're going to do a traveling road show with your machine.
That's awesome.
Go around and show them how to do it correctly. And then also I do want to take it into schools as well, to where at least give them a beginning of, 5-axis stuff, because, it's kind of hard in a high school or something to actually teach 5-axis, but at least get an impression of what it does. That's important that they see that, because, it's totally different than doing 3-axis stuff. You got to think totally different.
Do you think more technical schools should offer, because most of them do 3, maybe 4-axis. Do you think there is a need for them to offer 5-axis training?
Oh, for sure. For sure. Because you know how it's getting to where a lot of the simple work ends up either offshore or in Mexico or somewhere else where, if it's easy, we can offshoot it somewhere else. But 5-axis stuff, typically we keep that in the U.S., especially, if you get into defense stuff or nuclear stuff, we're going to keep that here. So there's always going to be openings for people that know how to do that. But like I said, it's a little bit more advanced training to learn that stuff,
And my last question is, do you think additive manufacturing will replace subtractive? Do you think the future of 3D printers with metal and things are going to ever replace, traditional CNC machining?
I don't think it'll totally replace it, but there's going to be a time when it's going to probably be 50 or 60% of it's going to be additive stuff. Because, even in aerospace, blades for jet engines, they're doing that more and more where, you take the used ones and build them back up and then remachine them. There's still going to be machining.
Right.
I don't think it'll ever get to the point where you could get the right finish and hold the tolerance with 3D printing. But, if you don't have to make it from scratch, it's a huge time saving.
Yeah, absolutely. I think like in time saving, do you think more in terms of programming or time saving more in terms of, long-term production?
Machining. Because like if you do a big blisk for an engine, it takes a while if you're cutting it from scratch.
Okay, that's very interesting. Well, thank you so much for taking the time to speak with me today, answer some of these questions. And I am, hopefully inspired a couple people watching to maybe start researching a CNC career in the future.
No, I hope so. We need more good people for sure.
Absolutely.
You know that.
I do. Yeah, that's our whole mission, right? Trying to fill that skills gap.
Exactly.
All right. Thank you, Jody.
No problem.